Alright, this is worksheet 6 of the polyatomic packet, and here we're going to talk about the bonding involved in polyatomic ions. Now, if we look at a polyatomic compound, so let's say, for example, we have our polyatomic that's positively charged, our ammonium, and it's going to combine with, let's say, chlorine. Alright, it's true that this is really an ionic bond. Right? We have a positively charged polyatomic being attracted to a negatively charged nonmetal. Simple enough. It's like the very first type of bonding we ever talked about. Okay? But what we're going to talk about in this worksheet is not actually that ionic bond, but we're going to look at just within one polyatomic ion, what is it that holds the nitrogen and the hydrogen together? Okay? Or, in another example, we could say, okay, maybe we've got sodium that has a +1 charge combining with the bromate ion that has a -1 charge. Well, sure, what holds the sodium and the bromate together is an ionic bond, but what is it that holds the bromine and the oxygen together? Okay? It turns out what's actually holding the atoms of one individual polyatomic ion together are covalent bonds. You know, the ones where they're sharing atoms, and that's what's keeping them together, rather than the attraction between a positive and a negative. Okay? So the pictures that we're about to draw are really similar to the covalent bond diagrams that you drew in the covalent compound packet. The only difference here is that these compounds, they've got charges, right? So our negative polyatomic ions have gained electrons. So when you do your very first step where you do that total electron count, valence electron count, you're going to have to add in a couple of extra electrons. And ammonium, which is a positive polyatomic ion, well, that means it's given away an electron. So you're going to actually have to subtract one from the total valence electron count. Okay, so let's practice with both a positive polyatomic ion and then a negative polyatomic ion. Okay? Everything's going to be the same except the very first step. So the first step, we're going to say, all right, we've got one nitrogen. Nitrogen is in the 5th family of the periodic table, so it's got 5 valence electrons. And we've got 5 hydrogens, which are each going to have 1 valence electron. All right? But in combining 1 nitrogen and 4 hydrogens, an electron has been lost. Remember, when we lose negatives, we become positive. So this has a positive charge because an electron has been lost. And so when we come up with our total count, right, which would be 9, we need to subtract 1 off of that because an electron was lost as the nitrogen combined with 4 hydrogens. So we really only have 8 electrons to work with. Okay? Now you got to be a little bit careful. You can probably see where people get confused. They think, oh, there's a +1 here, so wouldn't I put +1 here, not -1? Well, no, this +1 represents that a negatively charged electron has been lost. Okay? Alright, so just like before, now the rest of this is going to be the same. Nitrogen is our central atom because there's just one of them. And we're going to combine our attach the hydrogens with single bonds that each count for 2 electrons, which means we've used 1, 2, 3, 4 electrons. Sorry, that's not a double bond, that's a single bond. So we've used 2, 4, 6, 8 electrons in the process of just combining our outer electrons with our central atom. So we've used them all up, which seems like, oh no, we're going to have to use a double or a triple bond, but remember, hydrogens are our little babies, so once they've formed a single bond, their shells are full. And our nitrogen, if we count it up, has the 8 electrons around it that it wants. So this actually is our final answer. We can redraw it. Right? Remember, if you're using a pencil, you could start your drawing right in the final answer box. But there's our final answer. Okay, let's look at bromate. Bromate has a -1 charge. So when we add up our valence electrons, bromine has 7. Each of the oxygens has 6. Right? So 18 plus 7 more would give us 25. But look at, in the process of 1 bromine combining with 3 oxygens, an extra negatively charged electron was added in. So we're going to actually add 1 to our count of total electrons, which gives us 26, right? Okay, if you're doing some more of these problems and you get to a point where you've somehow added up an uneven number, an odd number of electrons, you've probably forgotten to account for electrons either being added or lost. Okay, because your total count of electrons when you do this first step should be even, because we always pair electrons together. Alright, so we've got 26 electrons to work with. Bromine is the only electron we have 1 of, so that'll go in the middle. We'll attach our oxygens. This is just like we did with covalent bonding. So we've used 2, 4, 6. So we've got 20 electrons left to use. So we'll put 2 on the central atom so that it now has 8. My subtraction's getting a little messy here, sorry. We have 18 electrons left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Perfect. Cool. Okay. So here's my bromine. Okay, now there's one thing that I forgot to do, so we're going to go back and do it on both of these. We have to remember that the only reason these structures could be the way they are is because of either gaining or losing an electron. So to finalize these, we're always going to put them in brackets, and then we're going to put the charge. So it's really just the same charge that was in the formula you were given. Alright, so this one we'll put brackets around it. And this is just to account for the fact that, yeah, here an electron was missing, and here an electron was added. It's because of those charges. Okay? So you will go ahead and finish these, and we will practice more when we get to class next.